because I always thought of myself, oh, data science is something that's all, oh, it's all programming. You must have had a degree in computer science. Yeah, you had to be a computer science background, I thought, to get into data science. And what I found actually was that a lot more of what I was doing, a lot more of the problem solving skills, I was already using the programming. I was already exploring big data. I was already developing predictive models. I just didn't call myself a data scientist.
Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Kathryn Berger. She is the data science team leader at Agrimetrics, and today on the podcast, we're going to be talking about data science. Kathryn's going to give us some insight into how she got involved in data science and what she looks for now when she's hiring data scientists for her team. I'll be back towards the end of this episode with a few points I would really like to highlight for you. But just before we get started today, I want to ask you for your help. I need help spreading the ideas that are contained within this podcast. I need help reaching people like us. And if you could help me do that, I would be very grateful. Welcome to the podcast, Kathryn. You are the data science team leader for an organization, and you've got this really amazing background in geospatial. Perhaps you could tell us a little bit about your background in geospatial and how you became a data science team leader, how you got to where you are today.
Yeah, so I have spent the majority of my career really focusing on using and harnessing data, and specifically geospatial data, to solve challenges of global health and food security. A lot more of my career is really focused on developing predictive disease models and maps. And I then turned my career exploring a lot more of my risk maps and risk models into expanding out through the agricultural food sector in exploring other ways to really use geospatial data. And right now, I'm using a lot of data science skills. I use data science to really help others make better use of their data, to explore and add value and really understand the power of the data that they hold. I got into geospatial actually, believe it or not, a long time ago, back in grade school actually. And that's much more to do with the Challenger disaster. And Krista McAuliffe, she was the first science teacher and astronaut. She was from my home state of New Hampshire, back in the United States. And she, before passing away in the Challenger disaster, was going to be the first science teacher into space. And her legacy really really supported a lot of NASA funded studies or work into the school systems, really getting a lot of students excited and interested in space and satellites and that kind of work. So we were using satellite data to explore forest health in grade school, going through the intricacies of how you could actually check out how a forest stand is doing by exploring data from space. And that really I got hooked at a young age from that. And everywhere along the way, I was kind of interested in how you could use satellite data to explore and understand and better observe the environment. So that's really what got me hooked from the beginning. And ever since then, I've been trying to use satellite data to solve issues, whether it's developing models to predict where the next disease outbreak might be, or whether it's to identify crops from space. I really, that's what excited me the most.
Would you mind giving us an understanding of whereabouts it was in your career where you started to think of your work as being data science?
That's a good question because I never really would have considered it being data science until much more of a later stage. Up until not too long ago, I'd say 5 years ago, maybe, because a lot of what I was doing was developing predictive models, was using programming skills, was solving issues. I had never thought of myself as data science up until it was actually labeled data science.
But did you consider it to be science, like scientific work that you were doing?
I always considered myself a research scientist, to be honest.
So you mentioned using satellite data, so geospatial data there. Was the geospatial bit of that, did it come into the conversation, like doing geospatial research, or was it just, scientific research for you?
For me, it was just scientific research. I liked solving issues with the satellite data. For me, it was exploring the problem. I liked solving the problem and exploring a problem. If somebody were to hand me a problem and say, all right, solve this issue, find the patterns, that's what I get the most excited about. And that's kind of where I targeted my career. I kind of followed the different problems of interest for me. And that would sometimes call me a disease mapping specialist, or that would call me, a research associate in disease patterns. So it was never that they really called me a data scientist. It was more down the road because I always thought of myself, oh, data science is something that's all, oh, it's all programming. You must have had a degree in computer science. Yeah, you had to be a computer science background, I thought, to get into data science. And what I found actually was that a lot more of what I was doing, a lot more of the problem solving skills, I was already using the programming. I was already exploring big data. I was already developing predictive models. I just didn't call myself a data scientist. I didn't think that I had the background to call myself a data scientist. I thought I'm a research scientist. That's what I do. I solve problems. I look at where the next outbreak of pandemic flu would be. That's what I was doing before.
That's really, really interesting. I think that we should save this sort of discussion around branding in terms of, are you a data scientist? Are you not a data scientist? To later on in the conversation. But for the first good chunk of your career, you didn't really consider yourself a data scientist. That changed somewhere around 5 years ago. And now you are the data science team leader for this organization that you work for. What was that like moving from this practical side of, let's call it data science, research, to being a team leader? Was that a difficult jump for you to make?
For me, it was a bit of a transition. Being a team leader was something that I hadn't necessarily considered, thought of. It was through a course of events that it was speaking up for representing my team. It was representing the data science side of things within the organization. And that was something, it was a position that evolved over time. So it was never something I sought out. It just evolved. And I think it's always been a learning and growing process for me.
That's really interesting. It sounds like you were doing leadership before anybody gave you the title of leader, and then it kind of evolved into a role at your organization. Do you think that's fair?
Yeah, I'd say that's a fair representation of what happened. That's something I hadn't thought of. And it was something that kind of naturally evolved as I represented the team within the organization and spoke up on behalf of them.
Okay, so you've got this role as data science team leader. What's it like now looking at your team? What kinds of skills are you looking for in the data scientists that you work with?
Within our data science team, we really have an array of backgrounds. And that's the really wonderful thing about it. The entire team isn't made up of folks that have studied computer science, done programming, have considered themselves data scientists from the start. A lot of us have come from different backgrounds, whether it's statistics, whether it's earth science observation, whether it's crop modeling. Everybody comes to the table with a different background and a different skill set, and we all use the data science skills to solve the problems at hand, so solve the issues at hand. And so a lot of the qualities that we're looking for, yes, we're looking for programming skills. Yes, we're looking for those machine learning, those statistics, those quantitative problem solving skills, being able to take models, develop them, further them. We want all of those skills, but we also are looking for folks that are able to see the big picture. I think that's one of the biggest things is to be able to use a lot of what we would consider soft skills, understanding the business issue. A lot of times we are dealing with communicating with a client. One of the biggest things, besides developing the really cool models to solve the problem, is to really understand the problem the client needs to solve, is understanding the data, how best to advocate better use of the data. What other data are we missing? And so it's really understanding and communicating. Communication is a big skill that I think it's not considered as often is really those skills of data science, the skills of visualization. Being able to develop an amazing model is one thing, and just a component of it. Being able to visualize the data to really tell that data storytelling, that's another key component. And having a lot of the domain knowledge that goes along with it. So whether you've got the background in say, soil science or crop modeling or anything for that matter, being able to understand, okay, what is the data actually saying? For somebody not familiar with the data, developing a model may make complete sense. You put the pieces together and it will tell you one result. But having that domain knowledge is going to tell you, hey, that model doesn't actually apply out into real life. There's some things that you need to take account. So it's having that really breadth of skills, having an array of complementary skills to match that domain knowledge, the machine learning, the programming, the data communication, the data visualization. I mean, it's having a whole set of these skills that really helps. That's what I'm looking for within the team. And to have the enthusiasm and just the willingness to just go after, take a problem and want to explore it, want to solve it, want to dive into it a bit further. That I think all of those skills combined, yeah, that's what we're looking for within the team.
So that's a lot of different skills there. I guess my question here is, how much of this do you think we can learn on the job? So I'm assuming some of these you need to have the certain prerequisites. If I'm applying for a job with you, you'll have some prerequisites. It might be a certain programming skill or a certain piece of software that I need to understand how to use. Could you give me an example of things that you are quite happy to help people learn on the job?
I think yes, a lot of times we have prerequisite skills, or there's obvious requirements for the job. Being able to program. There are a number of programming languages. For us, we're looking for. We work mostly with Python. Whether you work with Python, whether you work with R, a lot of those can be transferable. A lot of those, once you know one, you can really extend and learn others. And so that's something that if you've got the programming background, you can always learn on the job and adapt. But having that willingness and that ability to learn quickly is very helpful. We're looking for what was your background before? What are your quantitative skills? What kind of models have you developed further? What are your experiences in developing large predictive models? What kind of data have you worked with? We want to get a better idea of what you've worked with, what you've explored prior, and how you're able to think about it quantitatively, consider the problem, and how you can scale out. A lot of times, we don't want to develop just that one model or that one off model that's going to solve the problem. We want to figure out how to develop and deploy a model at scale. And that takes a whole nother set of skills. Often that set of skills overlaps, but that extends out of data science, whether it's a DevOps kind of engineering work.
Are you looking for any sort of formal education when you think about hiring a new data scientist? Or if I show up and let's say I have a ton of these skills that you mentioned before, and I can document the journey and I can show the things that I've worked on, would you hire me without a formal education, or is that a necessity?
That's a good question. Our entire team has gone through formal training, and quite often, actually, within our team, most have gotten a PhD within their own field, within a field within data science. If you can show the experience, if you can show the skills, that would be helpful. Demonstrating exactly your past experience, where you can go, the kind of models you've built, the kind of work, your other prior experiences, that will always help. Having the formal education is certainly not a 100% requirement, but it's often going to be something that it's going to make you much more competitive within the job searching marketplace in that way. It's not a requirement, certainly, but a lot more folks are going through and and gaining their PhDs, getting further qualifications in data science certifications. You're not required per se to get a degree in data science, certainly not. And I don't think that you need the 100% the formal training either. A lot of folks are self taught programmers, and a lot of folks can demonstrate kind of the growth or evolution over time into their career on how they've gotten there. So I don't think it's a straight answer. I think that it's a combination of things.
Do you mind letting us know how they demonstrate that? Like, is it simply just a few bullet points on their CV, or have you seen some really good examples where people have managed to really sort of demonstrate and document what they are able to do, the projects they've worked on before?
A lot of times, certainly within our organization, we often have, say, a problem that we've already prepared for them to. So we'd like to see how they're going to solve the problem, right? And we'd give them a kind of a data set, and we want them to show us and take it and make it theirs and develop a model off of it where they can demonstrate their capabilities, their data science skills. I think for us, I remember one time being very impressed by somebody who had taken the data available on our agrimetrics data marketplace without instigation. They developed their own models, they developed their own data visualizations, and they explored different trends about data that wasn't linked or no direct connection together. And they tried to show and explain what trends they might have found. And so it was something where they share with us exactly what our data might be telling them and explore and visualize what that kind of data was saying. And so it was really somebody taking the initiative, taking the first step to demonstrate a model that was showing different data feeds and how they could better tell a story from that.
That sounds like a really, really clever approach, taking that initiative and, coming with something that's perhaps unexpected. And I think that that sounds really smart, and perhaps some really good advice for other people that are in a situation where they're applying for work as well.
Certainly. I think being able to share your portfolio of the kind of work that you've done, or really take that initiative, demonstrate an example, demonstrate a tool, demonstrate something to us that we could find useful, might find interesting. I mean, I certainly that stood out for me as a candidate that somebody had took the time, wasn't instigated prior to. They just sent us an example of what they've kind of put together, and wanted to share how they might make better use of it, wanted to show how they could better tell the story. And that kind of initiative, that kind of problem solving, that kind of seeing the data and wanting to explain and tell more, that excited us because you can't teach that. You can't, that's a skill that isn't something you read in the books, right? That's something that you either have or you don't have. And that kind of excitement and wanting to share and explore the data and problem solve and have that enthusiasm, that's a real big ad for us.
Yeah, I mean, that makes perfect sense to me. So you mentioned like enthusiasm there, so excitement about data, what it could be, what we could do with it. Is it ever difficult with a team of data scientists to sort of balance that tension between enthusiasm and scientific research and the commercial nature of being a business?
Yeah, I'd say it's always an interesting balance. I mean, data science is not all about beautiful models and very cool machine learning tools. There is a lot of data cleaning, data processing, data wrangling. That's the less sexy side of data science that you don't hear people talk about on podcasts. But that's also a major component of the kind of it's the day in day out kind of skills that you need, and you need to, it's part of the job. And so kind of balancing some of those less exciting things with developing the very interesting models is certainly always a challenge, but it's kind of part of the process. You need to see what the bigger picture is, and I think that's always the key. It's understanding what the big picture goal is. What are we trying to identify with this? What kind of problem are we trying to solve with the data set at hand? What do we need to do to take it from point A to point B? And I think that's, there's often, I wouldn't say attention, but sometimes there's a lot of, certainly, especially with folks from the research background or within data science in general, there's a lot of let's build something, let's build a very elaborate model, let's build something with a lot of bells and whistles, let's kind of keep adding, let's kind of keep exploring we could ever evolve this kind of piece of work. And that's one of the most exciting parts of it, is trying to figure out different ways to model the data, different ways to tell the story. But then there's often the balance of being able to do something that's going to be efficient, that's going to scale out, that's going to be able to be deployed. You could build a model, a very elaborate, very amazing model that's going to solve a problem. But if it takes about 15 minutes to deploy and to run and to process, well, then somebody waiting on the other side, of our company website, waiting 15 minutes to get a result is going to be a little bit, that's, you can't deploy that. You'll get people impatient on the other side. You need to figure out how to develop a model that's going to scale. that's going to solve the problem. Let's say it's a classifying problem. It's going to classify the data, but it needs to do that with a certain sense of speed. It needs to be able to scale out to run smoothly as a process, so that you're balancing that ability to develop a highly developed classifier or a highly developed model, but it needs to be able to be deployed, to be run at scale, and to give results in a reasonable time. So that for that business end, they're getting results at a reasonable rate. They're getting answers. They're getting their kind of information in a balance that makes sense. So I'd say that's a kind of balance that always needs to be held. There's a lot of different components to try to both make the most interesting model, but then to kind of explore the many facets of the problem and to make the problem actually useful for the end user.
In your experience, how do data scientists generally react to this requirement that we need to have this sort of the business case for the work that we're doing? Are people like, yes, that sounds interesting. I want to be involved. I'm enthusiastic about approaching this in a slightly different way, maybe rounding off the edges, removing some of the bells and whistles? Or are they more like, my job is to do the science. Let me just do science?
I think it's always something that needs to be balanced and kind of reminded. Certainly, I think there's always the place for a lot more heavy R in the research and development. There's a lot more heavy research. And sometimes it's easy to get carried away. And I think that's where, when left to our own devices, we'll explore different facets of the problem. And sometimes we have to remind ourselves it's a business problem. We need to make the most out of the technical benefits of the model while also making sure that it's going to fit the requirements for the end user on the other side for their business problem. And so it's striking a balance, and it's making sure that we always have that in mind. So it's making sure that we make those considerations. And that's probably one of the pieces that we scope out in the beginning, so that we're always reminding ourselves exactly that kind of scope, the kind of requirements that are needed on the other end, the kind of, do you need to know these results? Do they need to be forecasted 2 weeks prior to when you're going to harvest your crops? Well, then that's something that we need to make sure that we build into the model. And so making sure that you get your answer in a proper time frame, and that you're getting that kind of problem solved, that's something that we have to build in from the start. And I think, yes, it's easy to get carried away, but it's also something we have to constantly balance. So that's it's striking a balance between getting into the ever, problem solving research component, making sure that that kind of problem is a business solution, that it's going to help the end user, that it's going to be something that's practical as well.
It sounds like you build a lot of these things in at the design phase, make it a part of the specification. So the specification might be that it has to complete an iteration in a certain time frame. It has to deliver a certain answer, kind of thing. And I think that's a really clever way of solving it, as opposed to trying to, again, round off the edges later on in the process, but build it in right in the start and say, we are finished when it meets this specification.
Yeah. It's always an iterative process. And for us, a lot of times it's going back to that client, that end user. So we work in an agile way. We're able to check in, share a lot of the progress that you've done for and with the client, and then make sure that that kind of feedback is helping to inform our further product development or further problem solving solution, while keeping within that kind of scope. So yes, we document that out first, but we make sure that we're always kind of checking back with the person or the organization that we're working with to make sure that it's really suited to their needs. And that's actually where a lot of that communication, that data science communication, that working with those kind of soft skills in identifying the problem and understanding the client's requirements and being able to think, okay, I know exactly how that's going to translate into a particular model, or I know that kind of requirement and what that's going to translate into down the road. Those are the pieces I was talking about in really being able to meld that problem together.
Do you think data scientists should be expecting to have a part of their work as being client facing, like what you're describing there? That communication process during those iterations of building a model or building a product, should they be expecting to go out and visit the client, sit at the table with the client, that kind of thing?
I think not every organization, each organization will have their own setup, but I certainly think that it is one of the key components. It's really advantageous to do to be able to communicate the kind of data science requirements and needs and understand the actual business issue, the problem that's needing to be solved there. I think that's what's going to help make you stand out, really. That's something that I find is essential. And I think it's very easy to kind of sit behind a computer, maybe always explore the data, maybe solve a problem, but being able to relay that data and the requirements and be able to communicate the results and what they mean, I think that's really essential, and that's going to be something that's going to help you stand out from a lot of other data scientists out there. And I think that's something that's going to be ever increasingly important. A lot of data science tools are becoming more and more accessible to people, right? And a lot of things are getting a lot easier. And so being able to translate and to identify the problem and to figure out the kind of the rest of those other components and communicate with the client and kind of sit with them and tell them, explain them, work with them about how their data can actually be used to benefit themselves. A lot of times somebody may have data, they don't even know how to make use of it. They might not, they might have a plethora of data, but being able to kind of work with them and figure out, okay, by taking these different data streams, we can really save you time and or money or make things more efficient. That's the piece that's going to be more helpful. That's the piece that really is going to help stand out there.
I think you touched on this next question a little bit in what you just said there, but I want to try and throw this out there anyway. How do you think the role of data scientist is going to change over time? Do you think it's simply going to be a matter of keeping up with the changes in technology? And you mentioned this idea that a lot of software is becoming easier to use. So oftentimes on this podcast, we talk about the idea of democratizing, technology and data and access to those things. So when you think about the changing role of data science over time, how do you see this evolving?
Yes, I think that's a really great question. There's a lot of models out there, and there's a lot of ever increasing complexity in the models and how quickly different classifiers, different machine learning tools are able to work. And that's always going to be something that's going to further develop and further expand. But I do think that really right now, a lot more of the different data processing tools, a lot more of the data science skill set, a lot of those tools are becoming much more accessible. And I think it's having the knowledge as to, okay, why would you use a neural network versus a random forest model? A lot of people will be able to apply those models and maybe get the results from what they want. But it's understanding why you are applying the machine learning methodologies to the problem and to the data set. It's trying to take all of that background, that domain knowledge, those statistics, those machine learning background and really use that knowledge to understand why you're applying a problem and how you would make better sense of the data. It's going to be taking it from that kind of data science and machine learning as a black box and wanting to make sure that you actually understand what the data is telling you and why you're choosing the model that you're choosing to solve a certain problem. I think it's going to be that kind of explanatory piece out of it, that kind of why you're doing what you're doing, that's going to really set things apart. Being able to apply the model to data set is one thing, but to be able to advocate as to why you're choosing one thing or over another, as to what other pieces, what other data sets, what other additional models you could add on to that, that's going to be what really sets you aside. And I think a lot of that's going to come back to having a bit of that domain knowledge, having a bit of that, those other complementary skill sets, those other complementary backgrounds that are not just getting into the statistics or the machine learning pieces of it. It's going to be the why. It's going to be why are you using these different models? How are they applying to biological processes? How do they relate into the real world? Why do you want to do this? And that's going to set it apart. That's where I think things are going to go down the road. I think it's going to be taking something that people are going to be able to use and apply more easily. They'll be applying it in a kind of black box format. They want to be able to understand the why, and being able to communicate and differentiate. That's what's going to help stand out down the road, I think.
Thank you very much for that. I really appreciate you taking the time to sort of walk us through that. And I think it's a really, really important message to get out there. We've talked a little bit about this need to communicate. We've talked about the ever increasing access to data and technology. And I'm kind of left wondering, do you see the role of data scientists perhaps being just as ubiquitous in organizations as the role of marketing or a role in finance in the future?
I think data science is going to be rather ubiquitous across a lot of organizations. I think right now a lot of organizations are trying to incorporate data science, but maybe sometimes they don't always know what that necessarily entails. They hear a lot of the buzzwords, they hear machine learning, AI, and they want to use it, and they hear that that's what's going to save them money, or they're going to make their results faster or whatnot. And I think you're going to see the use of data and data science throughout a lot of organizations. But I think a lot of times, and it depends on really the institute, the organization, the field that you're working in, how ready and how prepared they really are for data science. And again, it goes back to really understanding the data, understanding the field, the landscape. Take agriculture, for example. There is a plethora of data available, whether it's getting data from combine tractors, data from sensors on cows, whether it's using satellite data. There's an array of data out there, but it's really understanding how best to make use of it. You can have a number of different sensors and you can have a number of different data streams kind of coming in, but until you know how to piece those together and figure out what each data set is covering in that kind of landscape or that ecosystem, and then using that to make better sense out of it, you can have a lot of data out there, but you need to be able to mold it and to form it to try to figure out that problem area that you're trying to explore, to create a solution that you want to build and roll out. And so I think that you're going to see within a lot of fields kind of people applying data science out there, but it's going to kind of always have to be balanced in trying to figure out exactly what they mean by data science and what those requirements are. They need to understand their own data and the limitations of maybe the data that they have, to be able to figure out then how they can build bigger data sets, better data sets, how they can gather more data on a particular area to kind of focus and develop that understanding a bit further.
I think the irony here is that it sounds like they need, or an organization might actually need to employ a data scientist to figure out if they're ready to make use of data science.
Yes, I would say, ironically, that is often the case. And that on the data science side is often something where we go back to, again, those kind of soft skills and being able to, understand that, yeah, you're going to walk into an organization, they're going to have data, they're going to know that they want to make better use of that data, but it's not going to be, let's build this amazing model right off the bat. It's going to be, well, actually, we're missing a lot of data here. We want to solve this problem for X, Y, and Z, but actually our data doesn't fit that requirement. We need to, we have, say, monthly data, and with monthly data, you can't build daily forecasts, that kind of thing. As a data scientist, you may walk in thinking, all right, they're looking for a data scientist. I'll be ready. They'll have an array of data sets, and I can have fun. I can do that problem solving. But you go back and you kind of try to figure out, okay, this is how we need to solve the problem. This is where you need to make recommendations. And I think that's often the case as well, is that you're going to start off and say, okay, here's from my experience, from my background, this is where you might be able to add other requirements. This is where you need to get further data streams. And so it's going to be a multifaceted problem where you need to look and explore into what other data requirements, other pieces you'll need to kind of build out to get to where you can develop that really great model. And so, yes, it's kind of a circular process, or it's something, it'll be a learning process along the way. And that's where advocating and kind of advocating for better use of the data, or better understanding of the data, or piecing the data streams together is really going to be a good chunk of what you do from the beginning.
Kathryn, thank you so much for being here with me today, for giving us some insights and sharing your enthusiasm for the field of data science. I really appreciate it. You've been an absolute delight to talk with. Would you mind letting the listeners know if there's anywhere they can go if they want to reach out to you or perhaps continue this conversation?
Yeah, of course. And thank you very much for your time this morning. It's been a pleasure to be here as well. You can find out more, you can access more information about myself and my team at Agrimetrics. You can connect to me on LinkedIn.
Wonderful. I'll put a link in the show notes so listeners can easily find you there. Thanks again for your time. Again, really, really enjoyed talking with you.
Thanks again. It's been a pleasure.
I really hope you enjoyed that conversation about data science with Kathryn Berger. Kathryn is a data science team leader at Agrimetrics, and I'll be sure to put some links in the show notes to the different places that you can contact her, reach out to her. As a side note, I connected with Kathryn to the Women in Geospatial Speakers database. If you're looking for a collection of different voices from the geospatial industry, this would be a really great place to start. I'll put a link to that as well in the show notes. So there's a couple of things that I found really interesting about Kathryn's story. Firstly, about how she got the role as data science team leader. She was doing leadership and then was asked to lead. And I think this is a brilliant way to go about it. So the way I go about making a podcast is sometimes I have an idea and I go looking for a guest. And other times the opportunity to work with a specific guest is presented and then we look for an idea, some sort of overlap between the guest's expertise and what you, the listener, might be interested in hearing about. So there's always some kind of intent behind each podcast episode that gets published. So in this particular episode, the intent here is to give you a look into the life of a data scientist. So I found it really interesting talking to Kathryn because, she herself is a data scientist. But during the conversation, she by no means downplayed the need for scientific method, scientific rigor, but she did spend a long time advocating for all of the things around the science. So when I think about cartography, for example, we understand in our industry that cartography is this mixture of science and art. And it's interesting that we're comfortable with that when we talk about cartography. I wonder how comfortable we are with that when we talk about being a data scientist, that same understanding that there is a mixture here of scientific method, scientific rigor, and also art. And for me, the art side of things, that lies in the periphery, that lies in the overlap, where we move away from the science and start thinking about how this can be applied to solve certain problems. And Kathryn talked a lot about being an advocate, being a leader, advocating for the data, helping people understand their opportunities, helping people understand what they need in order to get to where they're trying to go in terms of the data science they are wanting to do. So again, I think this requires a certain amount of leadership and it requires a certain amount of generosity and it definitely requires a lot of creativity. And I think this is where the art side of things come in. It occurred to me that if you could do this, that if you could mix or combine science and art, if we can do that, if we can bring that combination of science and art to the work that we do, why, that would be remarkable. That would be the kind of moat that you could build a very successful career around. This would be the kind of moat that you could build around a very successful business or a brand. This would be the kind of thing that would be very difficult to democratize. Maybe the take-home message from this podcast episode is not just to do science, but to be an advocate for the science that you are doing. And I think when we are being an advocate, when we are demonstrating leadership, when we are acting as an ambassador for our work, for our science, for our craft, I think this requires a certain amount of creativity. I think that this requires a certain amount of experimentation. And perhaps it would be helpful to think of this as our art. Maybe that would give us the freedom we need to try different things, maybe to try things that might not work, and to experiment with intent. With the intent of making our work, our craft, our research more approachable and more relevant to the people that we are trying to help. And that's it for another episode of the Mapscaping Podcast. Thank you so much for tuning in again this week. Really appreciate it. I'll be back again next week with another episode. I hope that you'll take the time to join me then. In the meantime, if you'd like to reach out to me, you can find me on social media. I'm most active on Twitter and LinkedIn. You're also more than welcome to join the mailing list. There will be a link to that in the show notes. Okay. That's it from me. We'll talk again next week. Bye.